This example will be similar. The problem is find the fifth root. Sometime when we're finding roots of 1, we say find the roots of unity. So these would be the fifth roots of unity. The answer is in the same format as we had before. I write z to the fifth equals 1, and I can write 1 in polar form as e to the j, and remember, have to have multiples of 2 pi n in there in order to take roots. N, as usual, is any integer, positive or negative. Then when we take the fifth root, that is, raise this to the 1/5, we get z equals e to the j 2 pi n over 5. And when we take specific values of n equals 0, we get 1. That's e to the j times 0. N equals 1, we get e to the j 2 pi over 5, e to the j 4 pi over 5, e to the j 6 pi over 5, that's n equals 3, n equals 4, e to the j 8 pi over 5. I'll write one more to get the repetition, e to the j 10 pi over 5. But now 10 pi over 5 is the same as 2 pi, e to the j 2 pi is 1, so these are the same. And as before, we have exactly as many roots as we need. If you count them, you'll see 5 different roots here. Again, we can plot our roots on the unit circle. I'll draw my axes, quickly label them, real part of z, imaginary part of z. Then we draw the unit circle. See if I can get a circle here. It's almost a circle. And I can go and plot the roots. 1 is easy to plot. It's right there on the unit circle. 2 pi over 5 is just short of pi over 2 by 1/10 pi, so we'll put that there. 4 pi over 5 is 1/5 short of pi. We'll put that there. 6 pi over 5 is symmetric to that below the axis. 8 pi over 5 is down here. And there's that. So we have 5 evenly spaced roots around the unit circle. The angle between each root is 2 pi over 5. For this problem, I prepared some axes and nice circles ahead of time. The problem is to find the square root of 1 plus j. We proceed the same way. First example where the number we're taking the root of equals does not have magnitude plus j. And now we have to write 1 plus j in polar form. 1 plus j has magnitude square root of 2 and angle pi over 4. As usual, we have to put pi over 4 plus 2n pi, n equals 0, 1, 2, etc. And we raise this equation to the 1/2, and we get z equals root 2 to the 1/2 is 2 to the 1/4. Let me finish writing and then I'll say something about that. Then we have e to the j pi over 8 plus n pi. We divide the exponent by 2. Root 2 is a magnitude. When you take the square root or any root of a magnitude, then the root should be a positive number. That's why we simply took the square root of the square root of 2 and got 2 to the 1/4 as the magnitude. Well, there are 2 square roots, and they are 2 to the 1/4 e to the j pi over 8 and 2 to the 1/4. We'll finish by plotting the original number 1 plus j, I have to add its 2 pi to that, so I get 1 plus j has magnitude root 2, so it's out here on the circle of root 2. Let me label this circle as radius root 2. It's at 45 degrees, So if I can draw a straight line here, it's right about there. There's my 1 plus j. When I take the square roots, the magnitude changes from root 2, 2 to the 1/2, to 2 to the 1/4. That's a smaller circle. It's right here. The angle of the first root is pi over 8, half the angle of our original number 1 plus j. So we'll